Assalamu alaikum students. Hope you all are good. In our first online lecture, we have studied chapter number 1 of your physics books. Half of the topics were covered and some were left due to the time limitation. So sorry for that inconvenience. Let's have a review of the topic that were covered. We have discussed about the physics and its applications. Then we have discussed about the flow chart of the physics along with its fields or types. Then we discussed the topic of physical quantities. What are these? Two things were important into it, that is the numerical magnitude and measurable unit. Then we've talked about the types of the physical quantities. That are two, that is the base quantities and the derived quantities. Then we talk about the System International of Units, that are SI units. They are total 7 in number. They are also divided into two categories, that is the base units and the derived units. Then we have discussed about the scientific notation and how we can convert small numbers or large numbers as a power of 10. Then we talk about the prefixes. This is also used to represent the small or the large number in a standard form. For example, we used to add kilo, mega, giga, etc. And this was the topic which we were discussing on that day, the measuring instruments. So, the measuring instruments are used to measure different physical quantities such as electricity, frequency, time. For example, this is a sundial which was used to find out the time, to measure the time in the past. But nowadays we are using this clock in order to measure the time. So let's discuss some other type of measuring instruments that we use in our daily life. One of them is the meter rule or the measuring tape. This is an instrument which is used to find out the length of different objects. It is equal to 1 millimeter or 100 centimeter, and 1 centimeter is equals to 10 millimeter. Or we can say the least count of this measuring rule, a meter rule or measuring tape, is 1 millimeter. Whereas the length of measuring tape can vary from 20 meters to 50 meters, etc. In order to take a reading from this meter rule or the measuring tape, one should place his eye vertically on the scale in such a way that the eyesight or the eye is directly perpendicular on this scale. Let's discuss some other types of these physical instruments. Other type of instruments are stopwatch. Its least count is 1 centimeter. Measuring cylinder is one of the instruments used to check the volume of liquid substances. A beam balance is used to check the weight of an unknown object. In this, we place a known weighted object on one pen and an unknown weighted object on the other pen, and we compare the weight of both the objects in order to find unknown weight of an object. Then we have a physical balance. It is also similar to the beam balance, but it is more accurate as it is enclosed in a box in order to stop any effect of atmosphere on the measurement. If we compare these balances, then we can say that the physical balance is more accurate than this beam balance, and this electronic balance is better and accurate than this physical balance. Now let's talk about the vernier caliper, which is an instrument used to find out the external and internal diameter of an object or to find out the depth of any hollow cylinder. Accuracy is greater than 1 millimeter, that is, its least count is 0.01 centimeter or 0.1 millimeter. That is, it can measure the diameter of an object that is equal to this value. In order to find out the least count of the vernier scale, we divide the smallest reading on main scale by number of divisions on the vernier scale. By the smallest reading on the main scale, we mean that the difference in between the two lines of the main scale, which is equals to 1 millimeter. And by the number of divisions on vernier scale, we mean that the total divisions of the vernier scale that are equal to 10 most of the time. So when we divide 1 millimeter by 10 divisions, we get 0.1 millimeter or 0.01 centimeter when we divide it by 10, as a 1 centimeter is equals to 10 millimeters. Now let's discuss the construction of this vernier calipers. These are the two jaws. This jaw is fixed and this one is movable. These two jaws are helpful in finding out the diameter, the external diameter of any object. These are the inner jaws, and they are helpful in finding out the inner diameter of any hollow sphere or any hollow object. This is the vernier scale, and this one is the main scale. This is a screw which is used to tight the vernier scale after placing an object in between the jaws. And this rod is used to find out the depth of any object, for example, a measuring cylinder. Now let's talk about the working of the vernier caliper. So, if you close the jaws, these external jaws, and find that the zero of the vernier scale is in direct contact with the zero of the main scale, then your vernier caliper is free of any type of error. But what if it is not in line with zero of the main scale? Let's discuss this error or the problem that is in the instrument. Suppose we want to find the diameter of object, but before this, close the jaws of the vernier caliper. After closing the jaws, we find out that the zero of the vernier scale is to the right of the main scale, 0, which is considered as an error, and such type of error is known as a positive error, because it is an extra added value in the actual diameter reading of the object. So we'll subtract the measured value in order to get the accurate diameter value of object. So after this, find out which line of vernier scale is in direct contact with any of the line of the main scale. Suppose it's the fourth line, which is in contact with any of the line on the main scale. This 4 is only a number. We'll convert it into a standard form by multiplying it by the least count of this vernier caliper, that is 0.01 centimeter, and we'll get 0.04 centimeter. Place a positive sign with this number, but we'll subtract this value in order to get the accurate diameter. If contrary to it, on closing the jaws of the vernier calipers, you found out that the zero of the vernier scale is on the left side or outside the zero of the main scale. This is also considered as an error, and this type of error is known as a negative error. You will place a negative sign with this value and will add this value or this number into the main reading as it is decreasing the actual diameter of the object. Suppose the reading is again 0.04, as the fourth line of the vernier caliper is coinciding with the line on the main scale. The sign with this number will be negative, but we'll add this number in the main reading in order to get the accurate diameter of the object. Let's find out main reading by placing an object in the jaws of vernier calipers. Suppose the reading is 3.34. How? Suppose the zero of the vernier scale has passed 3.3 centimeter of the area on main scale, and the line number 4 of the vernier scale is in contact with the line on the main scale. Add these two readings, that is 3.3 plus 0.04, we'll get 3.34. And now from this number or this reading, we will add or subtract the zero error accordingly in order to get accurate reading. This is the link on the working of vernier calipers. I request you to please watch it in order to make your concept more clear. Now let's talk about a screw gauge, which is also used to find out the diameter of the object up to the value that is 0.01 millimeter, which is also considered its least count. Least count of this screw gauge can be found out by this formula, that is, least count is equals to pitch of the screw gauge divided by number of divisions on the circular scale. By pitch, we mean the difference in between the two lines on the main scale, which is equals to 1 millimeter mostly. And number of division on the circular scale, we mean that the total divisions on the circular scale that can vary from 50 to 100 to 200, etc. in order to have more accuracy. Now let's talk about the construction of this screw gauge. This is the stud and this one is known as the spindle. In between these stud and spindle, we place an object to find out the diameter of that object. This is a U frame which is fixed. This spindle is movable. This is the main scale. This line is known as an index line or the baseline. This scale, which is on the thimble or on the hollow cylinder, is known as the circular scale. And this is the ricket. Now let's talk about the working of screw gauge. It is also similar to the vernier caliper. On closing the stud and spindle of this screw gauge, if the zero of the circular scale is in direct contact with the index line or is perpendicular on the 0 of the main scale, then there is no error or zero error in your screw gauge. But if the 0 of the circular scale is below the index line, then your screw gauge has error, and such type of error is known as a positive error. Again, the same formula, find out the line which is direct in contact with the index line. Suppose it is line number 7. Multiply it with the least count of the screw gauge. You will get 0.07 millimeter. As it is a positive error, it will be mentioned with the positive sign. But you will subtract it from the main reading in order to get an accurate diameter of the object. And if after closing the stud and spindle of the screw gauge, you found out that the 0 of the circular scale is above the line of the index line, then in this situation, zero error exists. Such type of error will be known as negative error. Again, the same formula, find out the line which is in accordance with the index line. It is 58th line, but treat it 48th line. Minus this 48 by the total divisions on the circular scale that are 50. When you subtract it, you will get 0.02. As it is a negative error, you will put a negative sign with this number, that is minus 0.02 millimeter. This is how you find the negative error in the screw gauge and a vernier caliper as well. After taking this reading, as it is a negative error, so the process will go opposite and you will add this value in the main reading in order to get the accurate diameter of the object. Now let's learn how we can take the reading by using the screw gauge. This is the 0 of the main scale. This line represents a 0.5 difference. That is, the difference in between these two lines is equals to 0.5. So this is 0, 0.5, 1, 1.5 and 2. So your circular scale have passed 2 millimeter of the area on the main scale. Now find out the line on the circular scale which is direct in contact with this baseline or the index line. Suppose it is line number 25. Multiply this number with the least count of the screw gauge, that is 0.01 millimeter, and you will get 0.25. Now with the same rule, add these two values, that is 2 plus 0.25, you will get 2.25 millimeter. If you found a zero error, a positive zero error, then you will be subtracting this zero error from this main value, that is, and if your screw gauge contains a negative zero error, then you will subtract this value, the zero error, from the main scale reading or the main reading. Again, this is the link I've placed here. Request I request you to please watch this in order to make your concept much more clear about the working of the screw gauge. If we compare these instruments in order to find out which one is much more accurate, then the vernier caliper is more accurate than this measuring tape, and the screw gauge is more accurate and better than the vernier calipers, as the least count of the measuring tape is equals to 1 millimeter, whereas the least count of vernier caliper is 0.1 millimeter, and the least count of the screw gauge is equals to 0.01 millimeter. Now let's talk about the significant figures, which is probably the last topic of this chapter. In this, each of the digits of a number that are used to express it to the required degree of accuracy, starting from the first non-zero digit. Means these are the figures which are starting from a non-zero digit. But if we have 0 digits before this number, we will not be considering them as significant figures. So in this number 0.0701, the first significant number will be 7. The second significant number will be this. And the third significant number will be 1. Or all the accurately known digits and the first doubtful digit in an expression. For example, in 100.8 second, we have 4 significant digits. And in 0.00580 kilometer, we have 3 significant digits. And likewise, let's discuss how we find out that in this number there are 4 significant figures and this small number consists of only 3 significant numbers. Let's discuss some of the rules related to the significant figures. Before starting or learning the rules, let's discuss some concepts in this topic. These zeros which are starting the number are known as leading zeros. This is the zero which is in between the non-zero digits. These three are non-zero digits, and the zero which is in the end of the number is known as a trailing zero. So now discuss the rules of the significant figures. Rule number 1 says all known zero digits are significant that range from 1 to 9. So in this we can see 5, 8 and 3. These are the non-zero digits and they are significant. Rule number 2 says 0 between non-zero digits are significant. For example, 102, 2005, 5009. So these zeros will be considered as significant as they are in between the two non-digits number. Same is the case with this number 5083. The 0 is in between the two non-digit number, the non-zero digit number, so it is considered as significant. Rule number 3 says leading zeros are never significant. 0.02, 001.887, 0.000515. So these zeros are the leading zeros and they are not significant. Same is the case in this number as well. 0.00. These three zeros are the leading zeros of this whole number. Therefore, they are considered as insignificant. Rule number 4 is in a number with or without a decimal point, trailing zeros, those to the right of the last non-zero digit, are significant provided they are justified by the precision of their derivation. Example 389 000, 2.02000, 5.400, 57.5400. So, same is the case with this number. This is the 0, which is known as the trailing 0, as it is coming at the end of this number. So, it is also considered as a significant number. So, this was all in this chapter. Hope you've understood it well. Let's summarize it. We've discussed about physics and applications of physics, branches of physics, or we can say fields of physics. Then we've discussed about the physical quantities, the SI units, scientific notation, prefixes, measuring instruments, and in the end, the significant figures. Now, you people will be able to do your worksheets. I am waiting for 100% participation from your side. Thank you.